Hi, and welcome to this tutorial video on floating point conversion to decimal base 10. In this video I'm going to be converting this floating point number to a base 10 number. And I'm going to start off by marking out our Mantissa and our Exponent. So this part of the number here is our Mantissa. And then this part of the number here is the exponent. And I've got the stages of converting floating point numbers to decimal numbers over here. And if you follow these stages, you should be able to work it out. And I'm going to run through these now. So the first stage is asking us to check the sign of the Mantissa. So this leading bit here tells us what the sign of the Mantissa is. And in this case the bit is 0, and that means the Mantissa is positive. If it was a 1, then the Mantissa would be negative. Okay, moving on to our second stage then. Got to calculate the value of the exponent. So we've got to calculate what this binary number is in base 10, which is what the second stage is asking us to do. So I'm going to, if you've watched my videos on converting between base 10 and base 2, then you should be familiar with how I'm going to do this. So I'm going to write out the binary number here, and then write out the corresponding base 10 values. And I can see immediately that because I've only got a 1 here, then my number in base 10 must be 4. So the value of my exponent then is positive 4, and it's positive because it starts with a 0 here. So moving on to the third stage then, this is the most complicated stage because I've got all these instructions here of how to carry out this stage. But it involves moving the decimal point in my floating point number. So if my exponent is negative, I move the decimal point to the left, and if my exponent is positive, I move the decimal point to the right. And I've worked out in stage 2 that my exponent is positive, so I'm going to be moving the decimal point to the right. So if I write out my floating point number here, I'm going to be moving this decimal point to the right because my exponent is positive. And because I'm moving it to the right, I don't need to follow out this step, which is to a pad with 0s or 1s, depending on whether the Mantissa is positive or negative. I'll get to an example of that in the next example I'm going to do in this video. But I've got to move the decimal point 4 spaces to the right because of my exponent is positive 4. So I'm going to move this 1, 2, 3, 4 spaces to the right. So I'll write out my number again with the new decimal point. I've moved it the required number of decimal places to the right. So moving on to the fourth stage then, this asks us to, if the Mantissa is negative, perform 2's complement on it. And you'll know how to perform 2's complement on a number if you've seen my previous video on 2's complement binary. But as we worked out in the first stage, the Mantissa is positive, so we can skip this stage. And the final stage then is we've got to convert the number to base 10 using the fixed point method I outlined in my fixed point binary video. And what this involves doing is taking the Mantissa here and converting it into a base 10 number using our fixed point binary method. So just as I did in that video, I'm going to write out the base 10 numbers above it. being careful to write out the fractions as well after the decimal point. Now I can see if I add up my base 10 values, I'm going to get a total of 13.25. And that's how I convert this floating point number into decimal. And if you watch the second part of this video coming up in a few moments, I'll show you an example where I have to do this part of stage 3 and do this stage 4 here. Welcome to the second part of this tutorial video on floating point binary to decimal base 10. In this part of the tutorial video I'm going to be converting this floating point number here with this mantissa and this exponent into base 10. Now the first part of this process then is I've got to check the sign of the mantissa, and because our mantissa's got a 1 out the front here, I can tell it's a negative number, so because there's a 1 out the front, the mantissa is negative. Our second part of this process is to calculate the value of the exponent. So my exponent here, I've got to calculate the value of that in base 10. So I'm going to write it out, and then write out my base 10 numbers at the top here. You can see that I've got 1s under the 32, 16, 8, 4 and 1. But because my exponent is negative, because it's got a 1 out the front, this is minus 32. So my calculation to work out the value of the exponent is going to be minus 32 plus 16 plus 8 plus 4 and plus 1, and that's going to give us a value of minus 3. The third stage is our complex stage here, where we've got to move the decimal point in our mantissa. And for this one, because our mantissa is negative, we've got to move the decimal point to the left. And our exponent dictates that we've got to move it 3 places to the left, because it's minus 3. And if we're moving to the left, then we've got to pad with 1s, because we've got a negative mantissa, as we saw in our first step. So I'm going to write out the original mantissa here. I'm going to write out the new mantissa when I've moved the decimal point 3 places to the left and padded with 1s. Okay, that's my new mantissa. So that's step 3. And then in step 4, if our mantissa is negative, we've got to perform 2's complement on it. And in this case, our mantissa is negative. So the way we perform 2's complement on this is we look at our new mantissa here that we got from stage 3. Just write it out again. And then we've got to start from the least significant bit and move along our number until we get to the first 1. Leave that 1 as it is, but then the next numbers along start flipping the bits. So I'm going to write it out from the least significant bit again. And then when I get to this 1, I leave it as it is, but I start flipping the bits afterwards. So I'll change that to a 1, 0, 0, 0, 0, decimal place, and 0. Okay, now we can work out in stage 5 the decimal value of this mantissa then. And our decimal value is going to be, well, there's nothing before the decimal point, and nothing for these decimal places. This is going to be a half, this is going to be a quarter, this is going to be an eighth, this is going to be a 16th, but there is 2 1s here. It's going to be 1 over 32, and this is going to be 1 over 64. And after that, we don't need to worry because they're all zeros. So what we need to do then is do 1 over 32 plus 1 over 64. And if you do that, we'll get 3 over 64. And as a decimal, that is 0.0467. 875. We've got to remember that our number is negative. We've got a negative Mantissa here, and a negative exponent, in fact. So what we've got to add here is a minus sign to get our final answer. And that is our final answer. Okay, thanks for watching. I hope you found this video on floating point binary useful. See you in the next video.